दिसते का? Okay. So before heading to our software presentation, I would like to give you a brief introduction about our company. Our company name is Famic Technology, and before that, this is the agenda of today's webinar. Agenda of simulation of electro-pneumatics. Firstly, we'll see circuit design on electro-pneumatic PLC control, illustrated library, sectional components, pneumatic virtual trainer kits, teachware and workflow manager. We will see some industrial demo files. Then we will, at the end, we will have question and answers. Still, if you have any doubts or any question in between, you can type in your type in type it in chat box. We will try to address that. Okay. So these are the some webinar series which we have arranged organized with association with VVT Malaysia. So our company name is Famic Technology, and we have founded in 1986. Our company is ISO certified. We are more than 150 engineers and software specialists. Our Famic Technology is leading the industry by designing world-class trade-oriented tools in the field of fluid power, electrical engineering, industrial automation, and custom software development. Our We have three offices. Our headquarters is in Montreal, Canada, and two branches, Mannheim, Germany, and Pune, India. We have in-house expertise in software specialist, engineers, industrial automation. In software specialist, we do have software engineering, database design, network support, multimedia application, real-time system. In engineers, we do have engineering support, pneumatic, hydraulic, mathematical modeling, electrical system, automation, robotics, and manifold system. Also in industrial automation, we have PLC programming, SCADA system, human machine interface, electrical control, robotics, system maintenance. We have products like Automation Studio Professional Edition, which is used to create, analyze, troubleshoot, and validate multi-technology circuits in the industries only. Also, we have Automation Studio Educational Edition for the colleges and training institute to train future technicians and engineers on hydraulic, pneumatic, electrical, robotic, process control, and PLC system through simulation. We have special feature of Automation Studio Live Manifold, where it is also used in the industries, which is the complete hydraulics manifold software solution for design, coating, and prototyping. And lastly, we have Android Studio, which is more related to Industry 4.0, and it is used to complete or monitor complete solution of optimize your production objectives. We believe in long-term relationship with our customers, and we give after sales effective support by phone, email, or online. We have dedicated representative for each account. Also, we provide support material like training videos, demonstration files, quick start guides, etc. Today, we are going to see on Automation Studio Educational Edition. Before that, we will see some milestones by Famic Technology. As we have launched in the 1986, we were known as HydroSim and NeoSim. Then we have started Automation Studio version 1 in 1996, and till date we are on Automation Studio 9.0 and Studio 3.0 with our engineers and customers feedback. Automation Studio is a multi-technology software which we have parted our system software in three domains like system design, simulation, and machine documentation, where you can get system design on hydraulic, mechanical, electrical control, electrotechnical controls, electrotechnical one line, digital electronics, instrumentation, process control, robotics, PLC system, sequential function chart, which is SFC, workflow manager. Likewise, you can create these system circuits with the help of these main technologies. After that, you can create the simulation and animation of that circuits. And also you can make machine documentation like bill of material and reports, component sizing, energy consumption, teach where FMEA workflow manager. Likewise, you can use this. And our software fits in multiple programs like mechatronics, industrial maintenance, aviation maintenance, diesel, agriculture, and heavy duty mechanics, electrical, robotics, and automation, instrumentation and control, renewable energy, electromechanical technology, mechanical engineering technology, HVAC, marine technology, automotive. Likewise, our software directly fits in these many programs. Key benefits of Automation Studio for students, teachers, and schools. For students, students can validate theories studied in the class, and it can be illustrated system behavior dynamically in full image color. It allows to virtually test all types of systems for students. For teachers, they can facilitate demonstration of system interaction, and it enhances teaching and learning by working on virtual system. It, for schools, it eliminates the need to purchase single technology software as it is a multi-technology software, and it can be used in the conjunction with other departments. So within all departments, you can install the same software for all departments. Automation Studio gives you a special feature like e-learning or remote access, where in when license, uh, where you can give the assignments to the students and they can perform that assignment within their own space by giving the remote access to the students. You can control the time and date from your system. Likewise, you can give the uh, e-learning or remote access to the students. We have international presence. We are available in 13 languages in more than 150 countries, and it is used in the high schools, career centers, colleges, universities, workforce development. In Automation Studio, from these publications, we have created all the circuits and all the circuits are ready to simulate. Students and teachers just have to open the circuit and start the simulation and understand the behavior of all circuits and components. And for example, this circuit is created from the Fluid Power with Application by Anthony Esposito, which is this book. Uh, Likewise, similar all the circuits from these books are available in the Automation Studio. We have created interactive exercises like in Teach where you can see the circuits which are you can simulate, and while simulation you can understand the behavior of the component and give choose the options, question answers, give that, so you can understand these exercises and give the exercises to the students to perform. And these exercises we have built-in interactive exercises, so you can easily customize or you can create your own exercises. Digital twin of your own equipment, like colleges have this type of hydraulic or pneumatic trainer kit which they can work on that. But you can connect that hardware kit with our Automation Studio and get the real-time feedback of the circuit. As for example, we have created the same circuit with the help of uh, in the Automation Studio with the other components, uh, so it can be connect with each other and get the real-time feedback of the hardware kit. We have illustrated libraries for PLCs, hydraulic, pneumatic, HDC motor control, robotics, PLCs. Three ways to create, simulate, and troubleshoot. So, Automation Studio gives you three ways to create any circuit like symbols, illustrated components, virtual trainers. In symbols, you can see these are the ISO certified symbols. You can create your circuit with the help of that ISO certified symbols. Also, we have created illustrated components where you can get sectional view or illustrated view. So you can create the circuit with the help of that, which is fully in dynamic in color, and it is more um, enjoyable learning for students. Also, we have created virtual trainer kits. You just have to connect the remaining electrical connections and your virtual trainers will get created. Uh, Here is an example of virtual trainer plus versus hardware trainer. As this is the pneumatic trainer kit, you can see this is the hardware of pneumatic, and you can see is the same component we have created in the automation studio with same specification, and you can understand how it is easy to connect the components, so students will get understand how it is working, and they can perform the different circuits on that in the automation studio. I will skip this video as I we will see in the presentation of the software. So benefits of virtual plus hands-on experience. If colleges have hardware only, then three. If you take example three hydraulics trainer kits, then only two students per unit can work. And but if you have, and it is more expensive option. But if you have hardware plus automation studio, like example two hardware kit and 20 user license, then every student can work on the system, and they can take hands-on training with equipment where they can virtually test, troubleshoot, and validate circuits prior to the actual hands-on experimentation, which is in safe environment. Also, it gives you access to the number of components where and it allows them to create many more circuit and practice their own methods, and which is less expensive option for the colleges. We have a special feature in automation Studio, which is manufacturer's catalog. These are the pre-configured ready to simulate circuits, uh, uh, ready to simulate components which are created in the um, created by automation family technology company, and all the components which are real manner, we have created the virtual components in the automation studio, so you can choose any component and perform the create the circuit, and these components will give you the same behavior as from the hardware. So this is the interface of at manufacturer's catalog. We will see the and some components from the manufacturer's catalog at the time of circuit creation. This is a partial list of industrial clients. As we are available in aerospace, agriculture, energy, forest, defense, metallurgy, mining, handling, transport. Likewise, we have present in companies like Airbus, Boeing, NASA, AGCO, John Deere, ABB, Orano, Kubota, Caterpillar, Liugong, JCB Defense, China Steel, US Steel, Komatsu, Epiroc, Komatsu, Honda, Harsco Rail, Womack, TEDx. Likewise, these are some our partial list of industrial clients. If you have any question, you can put in the chat box. We will address your queries. Now I will move ahead with our Automation Studio software presentation. So this is the Automation Studio Educational Edition 9.0. Here Here are the some technologies which are available in Automation Studio, like electrical, PLC, robotics, hydraulic, pneumatic, SFC, craft set, instrumentation and process control, virtual systems, multi technologies, which is a template. uh, Default for today's creation circuit creation, I will take a default template. So this is a actual interface of the Automation Studio, where you can see on the left hand side you can see library explorer or generic component, which are where you can get all technologies regarding hydraulics, proportional hydraulic, pneumatic, proportional pneumatic, drive and transmission element, environment and control, instrumentation process control diagram, electrical controls, JIC and IC standard, digital electronics ladder diagram for Allen Bradley, IEC standard, Siemens, LS Electrical, Mitsubishi, electrotechnical IC and NEMA standard, electrotechnical one line, HMI and control panel, robotics. So these many technologies are available in Automation Studio. And on the and downside, you can see the frequently used components. You can zoom and zoom out, zoom in and zoom out to the component for better visualization. Here is the feature, so you can adjust as per your requirement. On the top side, you can get the ribbon bar where you can get home tab, edit tab, view tab, simulation. In simulation, you can get the simulation control, measuring instruments, dynamic measuring instruments, troubleshooting part, repairing tool, failure tools, fluid creation tools like video recording options, translation manager, workflow manager, student, which is a special feature in Automation Studio. It's a student tab which we have created specially for the students, as we know students don't use everything, uh, every feature in the automation from any software. So we have created the special feature so students can create any circuit within few minutes, as all the required features for the students we have gathered in single tab there, so they don't need to uh, waste their time to find any feature. That's why we have created the student tab. Also we have support and technical training material where you can get hydraulic, electrical, pneumatic, automation videos. On the right hand side, there is a project explorer where you can create new project or open and save projects. And also in the here you can get the tree of your component circuit. So we will start creating a basic pneumatic circuit first. So here in the pneumatic, you can see all the frequently used components are here. These are components which I am using. But if you are not getting any component here, then you can simply uh, expand the library pneumatic. Here you can get compressors and power unit, uh, all the components related to pneumatic like compressors, flow lines, reservoir, accumulator, actuator, direction valves, flow valves, pressure to control sensors, sequencers, relays, subbase, uh, logic logic units, timers. Likewise, any all the components related to pneumatic you will get it here. You can further expand the libraries likewise. So for today I will create one basic pneumatic circuit. For a circuit I will take one double acting cylinder. It's a double acting pneumatic cylinder. Now I will take one variable throttle valve with check. You can I need two, so I have dragged two components. I or uh, Here you can see the check valve with on the right side, but you can, if you want to change the orientation, you can change the orientation and transform your component from by right clicking. Here are the transformation: rotate 180 degree, rotate left, vertical, flip. Likewise you can change, but and you, if you want, you can move change the orientation by your keyboard with the help of shortcut keys. Now I need a direction control valve. Here are the direction control valves, but I will take this direction control valve here, 5 by 2 direction control valve. Now I need one pressure regulator. For that I will take relieving pressure regulator. I need one pressure or filter and separator. And lastly I need one pneumatic pressure source, which is a compressor like. So exhaust, two exhaust. So all the required components for the creation of the circuit I have dragged in the worksheet. Now we just have to connect the circuit. like we connect the wires and hoses. So we just have to connect the red ports. You can see how it is easy to connect the red ports. And for your information, these are which the lines which I am creating. These are not just any CAD lines. These are the hoses and pipes. You can give the pressure line, a pilot line, exhaust line. You can give. You can, when you double click on that, you can see data. You can modify that, like length, internal diameter, internal volume, perfect line. Likewise, you can modify that also. So these are the hoses. You can modify that as per your requirement. Okay, so we have connected the red ports and completed the circuit creation. Now, to whether to check the whether it's working or not, we just have to simply go in the simulation tab. Now start the normal simulation. Now you can see the different color in the different lines, and this line color showing color is showing the different pressure line in different pressure in the different line. So as it is on the retracted position, and our spool is in the for the retraction, and that's why it is showing red, as the pressure is high pressure in the system. So once you change the spool, you can see the color is changing, and our circuit cylinder is extending and retracting. You can modify the setting pressure, and by changing the setting pressure, you can modify the speed of the component, speed of the cylinder for retraction and extension. Okay, also you can on the red components, you can see the animation directly. Here you can see the animation cross sectional view of the component. So we know the circuit is working fine. You can copy any component by clicking Control and paste. Likewise, you can double click any component, see the data. Like these are the properties and properties of the component. You can modify as per your requirement, as these components are generic components. You can modify that. These are the force and builder variable assignments. You can connect the same circuit here, and we will check what can we how it will work. You can see both the cylinders are working at the same time, but if you change any property, like if you give any external load as 100 kg, you can see there is a difference between the pressure line. uh, I will delete this. You can measure the properties like with the help of conventional tools like flow meter. I will add the flow meter here, and one pressure gauge at this. So you can measure the properties like for extension of the cylinder 9.8 bar pressure is required, and flow is 0 in minus 20 around 30 liter per minute is the pressure flow. So you can measure that. But even as these are the some conventional components for measuring instrument, we have a special created dynamic measuring instrument which are dynamic nature. You can check the component dynamic measuring instrument, and these many properties like linear position, linear speed, output signal, For this I will check the linear speed, and here are the pressure in bar. You can check the differential pressure in the different points. Okay, now once you change the pressure, you can see minus 7 centimeter per second the speed of the retraction. 5 bar difference between these points, and 3 3 bar pressure is at this point, like 4.5. Likewise, you can measure the properties. Also, we have the feature like now graphical method. You can record this record option available. So once I start the simulation, this measuring instrument is recording the points. Now you can open the y of t plotter here. I will open. I will. Now you just have to drag the component in the graph. Okay. Now you just have to automate the scale. So you can see the graphical method of the cylinder extension and retraction as per these pressure points. You can measure that. You can see you can measure with the help of cursors. You can add multiple cursors and measure the different point. Like for these points, there is a delta t is equal to 3.32. For this point, delta is equal to 0.37 bar. Likewise, you can measure. You can copy the image, copy plotter image. You can paste it here, or you can paste in the Excel sheet or any Word format for your project work. So Automation Studio gives you a measuring instrument for graphical method also. I will delete this for clean. Also, we have the bill of material option. Here are the component name, quantity. You can modify the fields, like you can add. We will add the unit price. Here unit price has been added in USD, but it is showing zero as these are the manufacturer's generic component, not any manufacturer specified component. Now I will show you the special feature of Atomic Studio, which is online catalog manager. In online catalog manager, there are the com component manufacturers. So I will filter it for specifically for pneumatic. Here are the SMC Parker. I will take one S Parker pneumatic cylinder. Yeah, cylinder and actuator. Okay. So to use this component, we just have to create the part number. I am selecting it randomly. So here you can see to the piston 30. So we have generated the part number. So I will drag the component to the worksheet here. You can see the part number also is available here. Now I will just connect that and check whether it will work with the same system or not. So you can see my manufacturer specific component is also compatible with our other generic components, and it is working fine without any problem. So you can use the manufacturer specified components also with the genetic component. Now I will delete these components. Okay. Now you can see this is a pneumatic circuit. We can convert it to the electro-pneumatic with the help of we will work this circuit with the help of electrical circuit. For that I need to go in the ladder diagram. Sorry, electrical control IEC standard. Here I will take one 24-volt and common. I need one normally open push button. I will give name as S1 and S2 solenoids for extension, one more solenoid for retraction. So we have created this circuit for electrical connection, and so firstly these are the wires and these are the hoses, so you can't connect this with this as you will get the error, it will not get connected. So and for connecting this circuit with this circuit we have to make sure that our directional control has solenoids for, so you can take the any component solenoid operated directional control from this here directional valves 5 by 2. Here are the solenoids, but if you want to create your own as per your requirement you can modify. I will add solenoids. Okay, you can add here spring return. So you can see our component has been get updated directly. So now in variable assignments here for left solenoid extension and for right solenoid retraction. Now you can see our connections has made with the help of electrical circuit. It's working fine with the electrical circuit. Now we have completed with electro-pneumatic circuit. Now as per our agenda we have to see PLC control. Now I will delete this circuit, or firstly we will see illustrated components. Here in the illustrated components illustrated components, I will create same circuit with the help of illustrated components. These are the sorry. Okay, sectional components. I will create the same circuit. Firstly we will need one compressor here. Then I need one regulator. Pressure reducing valve. Need direction control valve on off. Solenoid operated. Now we need 1 meter in, meter out check valves. Yeah, total valves. And lastly, I will take one actuator, double acting cylinder here. Now, now you can see you can connect this circuit with the help of the straight lines. Also, we have the option like curved lines. So we will add. So you can see we have connected this circuit. Now we need exhausts, two exhaust. So we have connected the circuit. Now at the end we have to connect left solenoid, right solenoid we have connected for the retraction. Now left solenoid we have to connect with extension. Now once I start the simulation, you can see our both the circuits are working with the electrical control at same circuit. Now we can connect these circuits. I will delete this and connect, create here PLC cards. For that I will increase the page setup, zoom page. Okay, now here in the PLC, illustrated PLCs, here is a Siemens standard diagram. We will take Siemens schematic S7 1200. Now in generic component from IEC standards, here we have to get rung. Now we will add normally open contact, normally closed contact, and one output coil. I will copy the same here. Okay, now we need to add IC standard components. Line L1, neutral, one ground connection, one switch normally open. We'll give name as A, another one B. I'm moving fast as we will have less time. 24 volt and 0 volt common, and two solenoids, extension and retraction. Okay, so I have dragged all the components which I required to create the circuit. 0 and 3. Here also we will attach for the 2 extension for, we will attach at 0 and then 3 for 3. Okay, now we just have to simply connect the red ports. We will get link. So here we have attached the components to the Siemens PLC. Now we have to make the connection for the, we have to give the logic for the ladder diagram. Firstly, we will connect the components. Okay, now by checking, we have to give the connections properly. As this is the input, we have to search for IN or I. Here, firstly, you can see the first input is at 0. So we have to give the double click I00, and here first input upper output is at third. So I 0.3 output is at Q. uh, Q00, and for here I 0.3 00 and Q 0.3. So I hope we have made the proper connections. Now we have to make sure that connections here. For this also extension, and for right retraction. So now once we give the simulation with the help of PLC, you can see our circuit is working properly. So our PLC connections are made proper. So we are done with PLC illustrated sectional components. Now we will see pneumatic virtual trainer kit. In new project, here are the templates for hydraulic pneumatic. So in pneumatic, we have to open the virtual trainer kits, while here are the some pneumatic actuators, pneumatic on off. This is a blank template. You have to drag the components in the blank sheet, and then you have to create the circuit. Also, we have created one simple electro-pneumatic circuit. Here all the connections for the circuit has been made, and here are the electrical panel. We just have to make sure create the connections for the hard electrical connections. So for this for this circuit, I will make connection for the extension and retraction of this cylinder only. And this is the sectional components where you can see the symbols on the component, and these are the sectional views, sectional component of the pneumatic. So firstly I will, you can give a red connection at any of the red ports. For the extension I will choose momentary push button green color, and for retraction here we have missed to yeah, now it's proper now. And for the retraction of the cylinder I will choose the red color button. Now we have to give the connection to the uh, common or zero voltage. Now you can see our connections for the extension and retraction of this cylinder has been done. Now in the simulation, once I click on the push momentary push button, my cylinder is getting extended, and here it is getting retracted. So this is a simple extension and retraction of the circuit with the help of virtual trainer kit. Here you can see the options for light. You can give the connections for the light also, like for after extension my red light, green, my green light should blow. Now we will see. Now the green light is an off mode. Once my cylinder get extended, my green light should be get blown. Yeah. So once it is fully extended, then my green light will get blown. Once, as this is here, you can see the connection. It will get connected. Then my green light will get blown. So these are the virtual trainer kit of the pneumatic. Also, you can create your own pneumatic circuits, your own pneumatic virtual trainer kits with the help of blank sheet. For that, here the electrical panel is already available. You just have to drag your component, required components. I am just randomly dragging any component. So likewise, you can get drag the component, create the circuit, and connect with the electrical panel. Then your virtual trainer kit, you can it will get created. So if you have any virtual trainer kit in your college, you can make replica of that virtual trainer kit, hardware to virtual. So this is a available option in Automation Studio. Now we have done with pneumatic virtual trainer kit also. So there are other topics like teachware and workflow manager. Here in technical, here are the teachware materials for electrical, hydraulic, pneumatic. These are the demo files. Yeah, here is the teachware. It will get download, or I will simply open it from here. Technical training material, hydraulic, pneumatic. Yeah. So here are the pneumatic circuits for teachware. For physics, Boyle's law, Charles law, Gay-Lussac's law, ideal gas, components, door control. Likewise, these many options you have: filter design, filter overview, door control. So for today, I will open this teachware, door control. As this file is big, it is taking time to open. So now you can see here is the Here you will get the simulation circuit, and here you will get the component question answer. So you can modify, write your answer in text box, like you can give the date, like today's date is 3 so 6/3/25, and here student name, as my name is Manthan, I will give the name Manthan. So you can give the student name and then ready.
Welcome to this pneumatic activity about door control.
So there is a
Observe the circuit on the right and
or
wait until the system is stabilized.
there is a
Click on the push
audio
button
behind
once
me,
to activate the directional
which is
valve D2 and wait until the door has reached its open position.
and that lady is
Answer the
telling
first
our
question.
questions and the component behavior. So while this seeing this component, we have to give the answers. And what is the pressure read by the gauge DP1 during the ascent of the door? So here you have to check the component, and then I will randomly give any if I give this 15.
Now that the door is open, use the lever to switch the directional valve D1 to its left position. Then answer the second question.
Likewise, you have to complete the simulation as per her, as she gives us the instructions, and then we have to give the answers. This is a example of teach wear material. You can choose any teach wear material from this, or you can create your own teach wares and then give the assignments to the students. So this is a feature of special feature in Automation Studio. Now we have to I have some videos demo files for some industrial examples. So, demonstration. We have some examples. Yeah, this is a pneumatic example. Here is a video of the circuits. Here is the SFC graph set with the help of pneumatic circuit. Likewise, you have the options. These are related to SFC. Just a second. In industrial, industrial hydraulic and pneumatic examples. Yeah, these are the components related to pneumatic. This likewise typical tractor system schematic. So you can create your uh, circuits. These many complex circuits you can create in your system. So these are some industrial examples for of the pneumatic circuits. Also some, this is a hydraulic. Okay, so Let's see anything remain. Do you have any questions till now? And if you have any question, you can put in the chat box. We will address that. I'm done with my presentation. We will wait for a few minutes for your queries. If you have any question, you can put in the chat box. We will address that, or else you can mail us on the. Do you have any question? Please type in the chat box. We are open for the question and answer. You can send mail to this mail ID. If your queries you can send, or you can contact VVT Malaysia for further demos or any quotation, as we have created this webinar series with association with VVT Malaysia. So thank you for the joining and for today's webinar. Please do register for other webinars which are as per this aeronautical electrical circuit design, which is on 10th, 11th, and 12th. These many topics we will cover in further further webinars. So please do register on that, and if you don't have get the registration links, we will send it to you shortly. Thank you.